So we're doing U substitution, but with definite integrals. There is like a kind of a shortcut, I guess, which is the standard way to do it, but you might not. So let's go through it. So first of all, I would rewrite it as like from 0 to 2 of 8x times. To the negative second, right? So then what's u? U is 4x squared plus 4. The derivative of u with respect to x would be 8x. So du equals 8x times dx. So we're actually all set. We don't have to make any tweaks. I would stop writing right now if I were you. Just kind of watch what I'm doing. Then I'll go back and show you. I'll give you a chance to write also. So technically, if I write this at this point, that's incorrect. It's wrong because I have changed all of these x's into u's. Well, these are x's. So those also have to change into u's. These are no longer 0 and 2. So I'm going to erase those. You can start writing them. Just erase those two. So what I also need to do is I know that u equals 4x squared plus 4. So it's going, the 2 turns into 4 times 2 squared plus 4. So this isn't a 2 anymore. This is whatever I get when I plug 2 into this u equation. I have to change these x values into u's also. And u is given by this. So what's 2 squared? 4 times 4, 16 plus 4. So this is a 20. You can't switch part of the problem into u's and leave the other part of the problem into x's and expect it to like work out. So there's really an option here, but the other option sucks. So I keep like halfway talking about it. I should go through it, but I haven't yet. Well, I'm going to show you it, but you probably never use it. So change the 0 and the 2, so then 4 times 0 squared plus 4, so this is a 4 now. So then I'm going to integrate. So add 1 to the power, and now I can like go through and do, like none of this other stuff matters at all right now. I got down to that, that's my problem. I don't even know what the x's were to begin with. I don't care what the x's were to begin with. I've rewritten this problem like this. That's what I'm going to solve. So I'm going to add 1 to the power, which gives me u to the negative 1, multiply that by the reciprocal of that new power, which is negative 1. And then I've got a 4 and a 20. You with me? I'm just going to plug in the top minus plug in the bottom. So negative 20 to the negative 1 minus negative 4 to the negative 1. So what's 20 to the negative first? 1 over 20. And then I don't know if you guys were saying that negative or not, but this is just 1 over 20. And then negative 1 over 20. Minus, this is 1 over 4, and then negative 1 over 4. But then minus negative 1 over 4, so plus 1 over 4. And then like you can stop there, really. That's just addition, right? So if I wanted to keep going, this would be negative 1/20th plus 5/20ths. 4/20ths or 1/5. So it's multiple choice. You should do that. If you're at the gateway, you are allowed to stop there. I'm going to need you to start over. If you are doing U substitution and rewriting the integral in terms of u, then you got to rewrite these things in terms of u also. Whenever you do a new substitution. Yeah. It's a definite integral with u substitution. So when you're doing those two things together, that's what I'm trying to show. I'm gonna like back up in a second and show you the long annoying process you can do instead. I just want you to like see both ways. But before I do that, other questions on what I did right here? Yeah. I'm sorry, I forgot to. So that's the other thing you could do, but that's a lot harder. It's just more work. Because would you rather plug into that or that? You know? That? You'd rather plug. Okay, so. Alright, hold on. So if I go through it a different way, let's say I rewrote this and I did and it was the integral of u to the negative second times du. And I'm just going to like not put anything here. Because let's say I just decide I'm not going to do the problem in u's. I'm just going to use substitution to figure out the integral. I'm going to put the x's back. And then I can plug in x's. So I could go, okay, that's negative u to the negative first. I still can't put these there because those are supposed to be u values and they're not. But what I think a couple of you are starting to ask or realize is could I put those back in terms of x's? And now that they're back in x's, can I just use 0 and 2? Yes, you can. So you can decide to like do the whole problem in x's, or you can decide to do the whole problem in u's. Yeah, to me this is the long annoying part. Like to me, is it easier to plug into that or that, top or bottom? You gotta choose top every time. But you can make your own choice. Zach, were you like serious? You'd rather plug into this, or were you?
Yeah, he did it like really fast.
I'm not okay with you. Color, is that what you were asking?
Yeah.
Is that easier for you?
I mean, it just kind of makes more sense.
Okay. I don't like this because it feels weird to me to write this when I don't know, like, I'm just like leaving it blank. I don't know. And I think this is easier to plug into at the end, but it's your choice. You can do whatever you want. All I'm going to look at in the gateway is, you know, you're going to get to 1/5 or you're not. You know? Other questions on that one? That one's too similar. So none of the ones today, I didn't make any complex like ease or trig or anything. I just wanted to practice the like process. Tomorrow we'll do more ease and trigs and that kind of stuff. I do. But we're still working together up here, sir. Try it. You guys try it. Are we at that? Is that okay to say yet? Or should I do it? Try it one. So I guess you got to decide at the beginning. Am I going to work on my answer with x's or with u's? That's a negative one. 0 on top. Somebody. just cracking me up. This is pretty funny. Do you have a question? Just raging. I should tell you probably that the way you'd be taught in college is this way, where you replace the U's. Replace these with U's. I don't think it's a hard switch to make if you decide you don't want to do it now, but so I haven't done it like completely yet. But what I've got so far is if you're gonna get it into U's and then plug in, you'd be here. If you're like, no, I don't want to work with U's, I'm gonna put the X's back and then plug in, you'd be here. Again, if you're going to college and taking comp, they will teach you this way. So if you want to like get in the habit of that, that's up to you. I'm just giving you information. Negative. So instead of putting, you still have to do. You still have to do the U's. Which three? This? That one. So add one to the power, multiply by the reciprocal, and new power. Okay, so let me talk through kind of both of these. So you got to do this part, and like this part, regardless. So this is just me doing like my regular U substitution, and then I get it to here. So my choice from this point is: am I not going to worry about what these two things would be as U values? And this one, so here I'm saying I'm not going to worry about what these two things are as U values. I'm going to integrate it. I'm going to plug back in the x's, and then I could just work from there, and I didn't have to like worry about ever what these two things were as U values. So then I would go down here and say, okay, 2 times 0 squared minus 2 to the third minus, then plug in -1. this one. I got 8 doing this in my head. That to me is like way harder to do in my head or on paper or whatever. To me, it's easier to say, okay, I'd rather plug into this than this. So to make that happen, I also have to replace these two. I'm gonna take the 0 and the -1 and figure out what they are now in terms of U. And I know they flipped. That's okay. It just happens that you get a bigger number on the bottom now than you do on top. And now I can go get -2 to the third minus -0 to the third. So this is like a -8 basically, which is 8. And I'll get to 8 here too. But that's just going to take me an extra minute or two, I think. But again, it's not up to me, it's up to you, whichever way you're. Do you see the difference between the two methods and like what you have to do each one?
Yeah.
That's what I'm trying to get to. How many think you prefer this way? How many think you prefer this way? Okay. How many got 8? Either way, you guys. Okay. How many feel like you're ready for the worksheet? Teach the worksheet. Which way? I don't know. I thought I printed it. So I gotta go check. But you can like look on schools you before I get started. You're itching to calculate. So what I would recommend is you do number 2. We did number 1 and 3 together. I'd recommend you try number 2 both ways. And then once you've done it both ways,